In this video, I'm going to show you a couple of things you should never do to a 3D printer controller board. I have a 3D printer controller board here. This is the Duet Wi-Fi board. I have two stepper motors wired up to it, and I have the 4.3-inch screen version of the Panel Duet touchscreen control panel that can be used with the Duet series of controller electronics. Now, you've probably already heard that it's a very bad idea to disconnect stepper motors when the board is running. When you disconnect the stepper motor with current flowing through it, a high voltage is produced across the stepper motor leads, and this sparks across to the controller, and you can very easily damage stepper motor drivers that way. With plug-in drivers it's not so bad because you can just replace them, but with soldered-in drivers like this you really don't want to blow them if you can avoid it. So this is what not to do. Let's start by running a little program that's going to exercise the stepper motors. So this just turns the stepper motors one way and the other. I don't want to get an electric shock from this board, so when I'm unplugging these stepper motors, I'm going to use this bit of bubble wrap as insulation. So let's have a go at unplugging one of them. Let's unplug the X motor first. So there we are. Unplug the X motor and it's stopped. Plug it in again, driver's blown, it's not going to work. Oh, except it does. Ah, that didn't work. Let's try a few more times. Nope, still working. You probably can't see it, but there's actually a little spark appearing at the bottom when I mate and demate this. You can suddenly see a little blue spark there, and I can certainly hear it. But all of that doesn't seem to have stopped it working. Oh dear. Let's try the other one. Maybe this driver's a bit weaker. So we've stopped the Y motor now. Put it back again. No, that still wants to work. These motors are running at 1 amp current, by the way. And I'm using a 24 volt power supply. Well, that doesn't seem to be working. Whatever we do, it seems to carry on. So with a Duet Wi-Fi, disconnecting stepper motors when they're passing current is certainly not a surefire way of blowing them. And indeed, I've done this about 50 times on this board, and doesn't seem to have any effect. So let's move to another favourite way of blowing a 3D printer board. This is to short a high voltage like 12 volts or 24 volts into the thermistor inputs. Now this is quite easy to do if you get your hot end wiring mixed up. The hot end has heater wires going to it carrying 12 volts, 24 volts. Fan wires, also 12 volts or 24 volts, and of course the thermistor wires, which are going to the 3.3 volt ADC inputs on this processor. So given the processor doesn't like more than 3.3 volts in its ADC inputs, it would be a really bad idea to short 24 volts into them. So let's have a look at the readings on the Panel Duet. I've got some fixed resistors in there. I've got this one here on the bed input. I think it's 10k, and it's giving us a reading of 88.1C. I've got a 3.3k resistor on the hot end to simulate a slightly warm hot end. That's giving us 126.9C. Let's see what happens if we short this to 24 volts. So this red wire coming here into the terminal block, that's got 24 volts on it. So let's try connecting that to the live side, the ADC side of the hot end thermistor resistor. So I'll connect it there, and you can see the reading's gone to minus 273.1. So we disconnect it, the ADC is blowing. Oops, no, the ADC isn't blowing, it still says 126.9. Let's try it again to make sure we got it right. So I'll put that end on plus 24 volts. That end on there, and it's gone to minus 270.1. Hold there a few seconds and disconnect it. Note back to 126.9. Okay, well, looks like we can't blow the ADC up on this board quite as easy as you can on a ramps or most other boards. Let's try something else. Let's try connecting 24 volts to the ground side of the resistor that represents our thermistor. Again, this can happen very easily with hot end miswiring, so I'll put that end on 24 volts again, and this end on the ground side. So there we go. Oh, there's a little spark there when I did that. And as you can see, both thermistor readings are now minus 273, so it looks like something's blowing good and proper. But when I take the wire away, they both recover, so didn't do quite what we expected. Let's try that a few more times. So if we do that, don't know if you can see, but there's a tiny spark sometimes when I do that. There you are, a little spark, little blue spark there. Quite pretty. Nope, that had no effect. Let's try the bed thermistor. So that's 24 volts again there. That's the ground side. So, oh yeah, got a spark again. Both down to minus 273. Take it away. Nope, does nothing at all. Try a few more times. No, and let's check the live side, which is this side here. So that only affects the bed thermistor reading, minus 273. Take it away, and we're back to 88.1. So, creating a short between a high voltage 12 or 24 volt wire and a thermistor wire is not going to cause this version of the Duet Wi-Fi to give up. You remove the short and it bounces back again. And the same actually goes for the Z probe input as well. Now, of course, there are plenty of ways you can destroy a Duet Wi-Fi board, so I'm not saying this board's indestructible. There are shorts between different power rails, for instance, you could create that would destroy it. But what I hope I've shown is that for a couple of the things that commonly happen on 3D printers that you should try to avoid at all costs, but if they do happen on your printer and it's got a Duet Wi-Fi in it, it's probably not going to cause any damage. Thank you for watching.